Now observe that what we are doing in the second line, we are doing the zip of the transform of that classes, and that we are putting into the dictionary. Right. So that is just for the representation purpose. I want to display a particular feature and its class as a dictionary in output. So we'll not use these lines in a model prediction or anywhere else. We'll always use this answer, that is outlook underscore encoded, right? And similarly for temperature, humidity, and the wind. Fine. And remember that the play is our class label. Fine. So this is a dictionary representation. And these are the values that we'll use in our model. Fine. So now let's begin with the code development. First of all, the steps. So I will make sure that I will mention the steps so that you will have the idea that what we are supposed to do now. So the next step is we'll merge different feature to prepare the data set. So what we'll do in this case, right? Simply using zip, we'll create the feature set. So let's say if I give the name features, which is equal to, and if you recall that we have used the tuple right last time also. So zip and outlook is the name encoded. Yes, O is capital. These are the features, or you can say these are the X values. And if you just print that, right? So, and what is the meaning of this 1100? The first row, you can say, they are discussing, right? Where the first one value indicates the weather, second indicates the temperature, and so on, right? So now, next, let's just initialize this decision tree classifier. So let's say and just observe different values that you can use with this decision classifier. One is a which splitting technique that you want to use, whether you want to go for the Gini index or you want to go for the entropy, right? We have third measure. If you just recall the lectures, we have three different splitting techniques: Gini index, entropy, and can you just recall the third one? Uh, Actually, the names are Gini index, information gain, and the gain ratio, right? But as over here we are using the entropy, I guess you can recall what is the difference between information gain and the gain ratio, right? And what is the limitation of that information gain? Fine. So now over here we'll try the, let's say, Gini index is by default. So let's try the entropy. You can also try the Gini index in your machine. So we have just initialized the model, and the next step is we want to fit the model again. So we want to train the model. So which function we'll use for that purpose? Fit. Just observe the arguments. What will supply over here now? The essential thing that we need to supply is x and y value, right? So x as a x, what will supply? Features, right? So that's the value that we have just created in the cell number 9, and the y value, play, and specifically the name is play encoding. Encoded. And next, let's try to predict the output. So for that purpose, let's say prediction dot what predict, right? And let's supply some data. Let's say 1 2 1 0. Let's try to print the output. My bad. So output is 1 and 0, right? So the prediction is 1 and 0. And lateral, if you have the test set, you can also observe the set. This is a metadata, so we do not have the test set. Either we can generate the test set manually, or we can just observe the prediction output, right? So anyhow, we'll use the accuracy and that all measure in the next programs. So right now I'm not generating that. Another thing is we can a tree. You can just remove these comments. where we are passing this model to this export graph with function, right? Or another way, let's say if you want to draw the tree, one more thing that you can do is you can use plot tree. So and you can try some different attributes of this plot tree. So for that you can refer this scikit-learn documentation of this plot tree, where you can the next depth, the feature name, field, and so on. Also, it can display the impurity that we have, right? And so on. Also, the examples are given over there. So I hope this model is clear to you, and you can just practice this model. And if something is missing, then you can just try that thing. Maybe some different features you can try with this plot tree. The one interesting feature that you may like is the colored output, right? And so on. So you can try different features. You can also display the class label along with all the branches. So for that, you need to use that class name, and you can specify the class name over there. So it will display the class name too. So I hope this program is clear to you, and you can practice that program. And maybe after 5 minutes, will resume with the second program. And those who are clear with the first program, just give a try to a second program, where once again we'll use a decision tree, but now with the iris data set that we have already used in the previous laboratory. So you can just take a reference from the previous laboratory, the naive Bayes algorithm, how we'll deal with that iris database, or let's say the assignment that you might have developed for that, maybe some other data set, not the iris. So you can just take the reference for that, and you can use trend, test, split, and so on, the other features, right? So what you are supposed to do, it is already mentioned in the comment. So just try to, okay, I will repeat that, Janik. So just try to go through this particular second task, and also observe the exercise which is given at the end. And if we just see how we can draw the tree, right? And also take a reference from sklearn tree, the plot underscore tree method. So we'll have a look at that particular manual page of plot tree. And personally, I haven't explored this second method. I have just used this pre-available code, so I'm not very much familiar with that code. So that's why I'm not exploring that code in a more depth. But yes, if you just see the function, it's very easy or very clear to all that we are specifying the features, then the class name, as well as the field we are using over here too, right? You may find more detail of this, but personally I prefer the first version, that is plot underscore tree. So just quickly go through this code. If some doubts are there, let's just discuss that. And if no doubts, then we may proceed with the second file, right? And then later we'll see the third part, which may be interesting part for you. So what I expect that at the end of this subject, if everyone is not clear with all the fundamentals, then at least you must be clear with the process, right? What we are actually doing: trend, test, split, then what is speed, what is transform, and then what is prediction, and how can we calculate the accuracy, right? So for any model, any given model, you should able to at least understand that. So if everybody is able to understand that, and that's what I want, right? Definitely we'll discuss more than that, but it's fine if you're not able to get each and every concept, and if you're just able to understand that given program. So let's say if somebody gives you one machine learning model, the full code, then you should able to understand what exactly the meaning of individual code or individual line. So maybe at 10:50 we'll resume the discussion with iris dataset, right? Any doubt in this first program? Meanwhile, whenever you are trying this first code, in between, if some doubts are there, then we can just talk on that, and otherwise we'll continue with the second part. Is it fine, Akshay? Initializing the decision tree. The last step means prediction or the tree creation. Okay, so that is just for the visual representation of the tree that is generated by this model, right? So there are basically two ways to do that. The one is using. Is it fine if I just move this cursor, Akshay? So there are two ways to visualize a tree. Okay, Akshay. One is using this plot underscore tree, and another one is using this particular module and using this function or the method export underscore graph quiz, right? So with using any of that, you can just visualize the tree, or you can just draw the tree which is generated by your model. Fine. So that's the only role of that function, and you can have more detail of that plot underscore tree over here in this sklearn standard manual. Right. Also over there you will find the detail of the other function. Okay, so now let's start with the second file. So I hope many of you have tried this second file, and let's just see. The first step is we want to print the name of all 13 features that are there. So let's say print features, and how can we print the features? Iris, the feature name. What is the underscore name or names? Okay, names. Needs class and target names. Right. So there are three classes, and if you just print the shape, and there is 50 row and 4 columns where each column is related to that 4 features, where the features are length and width of sepal and the petal value, right? And we have 3 classes for that. So now this train test split. So let's say x train x test y train and y test. What will be the first input to this? Data, right? So this dot data. Second would be the y value, that is the target value. Iris dot target. Let's say we are setting that test size to 0.3, and let's say the random state value, let's say 10. Right. And what is the meaning of this test size 0.30? 30% will result for the testing, and the remaining 70% we are using for the training. Fine. Next, creating the decision tree. So we know that how can we initialize a decision tree, right? So let's say classifier is equals to decision tree classifier And now we'll use the gene index. Let's say we are also trying some other parameters. Maybe let's say we can try this max leaf nodes. That's 100. So these are some techniques to restrict the decision tree. Let's say the pre-processing techniques where you can specify the maximum. The meaning over here is the maximum leaf node that we want is 100. So if leaf nodes are higher than 100, then we should stop generating a new or stop splitting further, and we'll just label all the examples which are present right now in the current node, or we'll just label the current node as a leaf, and value, or you can say the class value for that current node will be the maximum of all, right? So we have seen this thing in the lecture. How can we use that maximum what feature, right? And also there are many other way to stop that, or you can say many other way to prune that particular decision tree, right? One is by restricting the maximum number of leaf, and another one is by, you can say, the technique that we have seen in this regression tree, where we are saying that the minimum number of the minimum number of example, right? So if number of examples are uh, higher, let's say if we set it to 10, so for any node, if number of examples are higher than 10, then we'll split, otherwise we'll not split that node, and we'll label that node as a leaf. And so that are some way to handle that pruning. And so our classifier is initialized. So now let's try. And okay, so what will be the argument? Intentionally I'm repeating the same thing again and again, so that at least at the end everybody must clear with the argument, with the feed function, with the prediction function, and that's what I want, right? So what will be the argument of this feed? So x train and y train. Fine. Next, the prediction, and let's say the name that I'm giving is prediction. And what will supply over here? In the prediction, what will supply? X test, right? મેં પહેલા પૂછ્યું ત્યારે ઓડિયો જતો રહ્યો હતો. X test. So for a given X value, it will predict some result. And now let's use the accuracy measure. Matrix dot. Let's just try the confusion matrix first. Confusion. So now what we'll have as an input to this confusion matrix? Yes, so that is n, right? So y test, it is this value, right? And this prediction is the value which is predicted by your model. So very good performance you can observe from this particular answer. And let's try to print the accuracy. is metrics dot score. Okay, so around 98% accuracy we have achieved on this very clean data set. So that is not a very surprising thing, but yes, the data set itself is very clean. So this accuracy that we have achieved, and at the end you can just replot the given graph. Right, I'm not doing the same exercise again, but if you just uncomment this particular code, you can draw the graph or you can draw the tree. Fine. So let's try the our approach. Right, actually we have three class label over here. You can just give accurate name. So these are actually the class labels. Better than writing that yes, no, and all. Let's just write that class name itself. Okay. And now if you observed, one thing that I want to highlight over here is the tree which is generated is a binary tree. Thanks to question mark. If you observe the generated tree, it's a binary tree. Why? Yes, thanks to Gini index, right? So I hope this second program is clear to you, and just go through it if you have some doubt. Otherwise, we'll move towards the third program. Fine, and once again, the exercise similar to the last lab. You're supposed to complete two tasks with different training testing division with different random set value, and you have to answer some question for both models. So in this plot tree, remember that we are supposed to supply our model only, right? So that is CLF. I was wondering why nobody is answering. Okay, so sorry for that disconnection, and let's continue with the third file now. And I hope you have completed the second file, and now I am audible once again. Yes. So just go through the given data set. How many columns are there? Just open the data set, that CSV file with maybe if you have Excel or some other tool. So just open that CSV file and observe that how many columns we have over there. So two columns are there, where the first indicates the label and the second column indicates your text data, right? And I have minimal version of that. That is a spam1.txt where I have removed some content or some code from the some lines from this spam data set, right? So we are just creating this top word list. Then we are using the pandas to read that CSV file, right? And using the dataset.info, we are just displaying the information related to the data set where there is a no null entity, the two column B1 and B2, right? And we are also representing the data. Fine. Now, today, if you just recall the previous process, what we were doing so far, we're doing the label encoding where we are converting the given words into some number, and then lateral we were proceeding with the model, right? But right now, if you observe the text data that we have, we cannot just blindly try the random label encoding and lateral we can proceed with the model, right? Or we cannot just use the label encoding plus padding also, but you need to use something where let's say if I just give you one example. What we want for every word which are present in our vocabulary, right? Last time we have discussed the concept of that vocabulary and the data set, right? So for every word which are present in the vocabulary, what we'll do, we'll create one feature, right? So let's say one feature is win. Let me just write it over here. Another feature can be, let's just assume a very simple model where we just have three words in our vocabulary: win, enjoy, and the hello, right? And let's assume we have three training examples, 1, 2, and 3, and class of, let's say, 1 and 2 are 1, that means it's a spam text, and the third is 0, that means it's not a spam text, right? And assume that whenever it's a spam text, it contains the word something like this. Right. This is a very basic model for understanding purpose. Actually, in a real world, we do not have a very small model like this. But what I want to highlight over here is, so we are observing, if we just consider this first row, what we are observing that in a first example, we have two words, win as well as enjoy. Fine. So over here, one means the word is present in the particular statement or particular sample, right? So these two words are present, while the hello, let's say, is not present, and we are saying that the class label is 1. Second example, we just have one word that is win, and no other words are present, and still we are saying that the class label is 1, right? And the third example, where we just have the hello present, we do not have the words like win and the enjoy, right? And the class label is 0. Fine. So basically, now what you need to assume, you need to assume that every column is your feature. Fine. And what we want, the machine learning model that we are using, it will try to find the relationship between a particular word and the class label. Fine. And now consider in terms of decision tree, what it will try for this win, enjoy, and hello, it will try to find how pure the class label is, how pure the class is. Fine. So just by looking at this example, can you just imagine if you try the decision tree model over here, which will be your root node? Chintal is saying win. Mayank, Jainik, win. What if I say hello? So that can also be pure classification, right? If I consider the hello, that is also pure classification. So either win or hello, rather than just saying either, rather than saying win or hello, we can say either win or hello, because both will purely classify your data into a separate group, or you can say that are the pure division. Fine. So that's what we want to create, right? So assume that the first statement is you win, enjoy. And the second statement is win, let's say win-win. The third statement is hello students. Hello, or let's say, well, assume that the student and you are our stop words. So let's assume that we have removed that words before doing all this processing. And so this is my first statement, this is the second statement, and this one is the third statement. Fine. So now if I blindly just use that label encoding, then what happened? The encoding for the first example, right now the encoding for the first example is 110. Fine. But if I just use that label encoding, what label encoding will do? It will identify there are three words: enjoy, win, and let's say hello. Fine. And it will try to find what is the relationship, or rather than relationship, what is the occurrence of that particular enjoy, win, and hello in your data set. Fine. And also it will add padding. So now what happened? Let's assume that your data set length is 4. Or let's say we are setting that try the padding and put the length as 4. So can you just encode, let's just give a number. Let's say this is 1, 2, and 3. Can you just encode the first statement with pre-padding using the label encoding? So what the answer? I just want the answer, not the actual code. Once again, I'm repeating the question. Assume that the labels are 1 for enjoy, 2 for win, and 3 for hello. And what will be the encoding, label encoding, with length is equals to 4 and pre-padding for our first statement, that is you win enjoy. જતો રહ્યો પાછો અવાજ? Am I audible? Yes. So are you getting the question? Or some confusion? Okay, so let me just repeat that. I hope you are aware about the label encoding. Label encoding, what we are doing. So let's assume these three statements are there in my data set. We are considering that very small data set with these three statements. Statement number one, that is you win enjoy. Statement number two, that is win win. Statement number three, that is hello students. Right. Then we'll identify that you and students are the stop words. So we'll remove that stop words, right, before doing any further processing. Clear up to this point? After that, after removing the stop words, we'll try the label encoding. And let's say this enjoy is encoded as label 1, win label 2, and hello label 3. And now for our three statement is 1, 2, and 3, that is for this you win enjoy, win win, and hello student. We want to see what will be the representation of that if I try that label encoding plus padding, where the padding that I'm using is pre-padding and the length of the statement that I am keeping is 4. So now can you just tell me what will be that 4 values for each 3 examples? So first of all, what should you do is, let's say the first example, in the first example, which words are there? Win and enjoy, right? So for win, what is the label? 2. For enjoy, what is the label? 1. Fine. So ideally the labels are 2 and 1. Clear? Then if we consider win-win, we have win word twice. So what is the label for win? 2. Right. So we'll write that 2, 2. And the third, we have the word hello. The label encoding for hello is 3. So we'll write 3. Right. But as I've explained that we are using the padding, and the padding that we are using is pre-padding with the length as 4. So I need 4 length string with initially padded with 0. So the first string would be 0021. Second will be 0022. And third will be 0003. Does it make sense? And I hope we have discussed in the last laboratory that what is the role of padding, because any machine learning algorithm need all the samples are of same size, so we need to pad the examples, right? So are we clear up to this point? Because this is very essential why we are introducing the new technique rather than using this label encoding, why we are doing something else. So you must know what is the limitation of label encoding over here. Are we fine? If you observe this encoding and just consider the last column, we know that the one column means one feature. And let me just rewrite the class label also. So what is the relationship between the last column and the class label? We know that the one column means one feature. So what is the relationship between the last feature and the class label? No relationship. Agree? Right. Similarly, find what is the relationship between this feature and the class label. Understand? Test to the wine for first as well as for the second. Once again, no relationship. Right. So the feature that we are designing right now, there is no impact of that feature on the class label. So how the model will learn something from this? Are you getting? What is the intuition why we cannot directly just use the previous technique that we have discussed in the last laboratory, label encoding and the padding? Because we know that the one column means one feature, but this feature does not represent any relationship with the class label. Fine. So that's why in this example we'll use something else. Right? So there are many ways to deal with this. We'll just try the first version, that is binary term frequency. Right. So this many of you might heard about this TF-IDF. Anshuman, Anshuman present? Yes. Okay. So do you want to comment on this TF-IDF? You can just unmute yourself and if you want to. Okay, mic is not working. So you can you type that? Just a full form, right? If the mic is not working, then I can expect that the full description. But Anshuman is aware about this TF-IDF. So the TF means the term frequency and the IDF means the inverse document frequency. Right. So this will map the features, right? So what we will do basically, let's just try one by one document frequency. What we'll do for all the words of our corpus. Corpus means the data set, right? So in the last lab we have discussed this term. So for all the words of our corpus, we'll try to check how many times that word is present in any of the document or any of the data set or any of the row. Fine. So we'll count that number, or you can say we'll count the frequency, how many times that word is present in my corpus. Fine. So that is the term frequency. So whenever I say a particular word, so let's say some XYZ word, it is a very frequent word. That is a very frequent word. સૌથી વધારે વખત એ word જ આવે છે. So what's your comment on that word? Can I say that word is a very important word? Mayank says yes. Now no. And what if I say your both answers are correct? We can say that's an important word if we have already applied the stop word removal. Otherwise, we can say it's not an important word. Agree, Mayank? Right. So why Mayank has changed the answer? See, basically, whenever you have a very frequent word, most probably it's a stop word like the, is, a, n, and so on. Right. So before doing any of this processing, it is very essential to remove the stop words. Otherwise, always the stop words will have the higher frequency than the important words. Right. So now if you remove the words, now the term frequency, or you can say the frequent word, if you just remove the stop words, now whichever frequent words are there, can I say that that might be the important word? The author, or let's say in a corpus, whosoever has written that corpus, it is frequently used word. right? So that is captured by this TF, that is term frequency, right? And to enhance the performance of TS, we'll use one more factor, that is IDF, that is inverse document frequency. Means we'll see in how many samples, how many row that word is present. Let's say if I say that that word is present in all the row or all the examples or all the documents, then inverse of that will be considered. Why? Because if it is present in all the document, we cannot say it's an important word, or it cannot describe what is the important concept of that particular document or a line. Agree? Assume that for more clarity, assume that you have one document on the operating system where each line will represent, or let's say we have the operating system textbook, fine, where one line of the textbook will say that is one feature, or rather than one feature, one sample. Are you getting? One line means one sample. Operating system ની ટેક્સ્ટબુક ના જેટલા બી સ્ટેટમેન્ટ છે દરેક સ્ટેટમેન્ટ એક સ્ટેટમેન્ટ, right? So that is a X, where individual word is the feature. સમજાય છે? This is very important discussion, right? The TF IDF is a very popular term if you are dealing with the NLP. So now, if let's say if we consider, if we think about the word operating system, can I say that in almost all the document, and whenever I say word document, that means all the statement. Can I say that in almost all the statement, the word operating system is there? Right. So if it is the scenario, then can that word operating system uniquely identify what's a special thing in that particular statement? No. Right. So that's why that frequency we should take inverse of that frequency. Instead of that, let's say if I consider the word bankers, right, the bankers algorithm. So if that word is present in, let's say, only 3 line out of, let's say, 1000 line, only 3 line contains the word bankers. So can I say that the banker is a bit important word, or you can say that is something which is a representation in that line only. So that 3 lines speak something about the banker, rather than we can say that 3 lines speak about the operating system. And so that is important for us. Does it make sense? So that's why we are taking the inverse of that. And if we multiply this inverse value with the TF value, then we'll able to get a good result. Fine. So with this basic intuition and with this basic understanding that we cannot use the direct label encoding over here, let's try to have some other technique. And for that purpose, let's just first separate out the X and Y. Let me know if you have some difficulty in understanding these lines. fitting on the test data. It's just an label encoding. Right, so that is the 1010 value we are assigning to spam and the not spam text. Right, we are not fitting anything on the text data. So we are just try, right. So now for further processing, I would like to discuss this count vectorization. And one very good example is given over here. So let's just first discuss that example. So assume that to understand this count vectorization, assume that you have this corpus, or you can say this is your data set. This is the first document, this document is the second document, and so on, right? And we are using this count vectorization on the corpus. So fit transform, and that will be our X set. Fine. And now if we try this vectorizer dot get features name, so which features we have now, the words which are present over here in this corpus, all the words of your dictionary, you can say. And so that are your features. And now if you try to print this X, then your output is something like this. So can you tell me what is meaning of this? Yes. So, no, that is not the pre-processing. But what Vivek is saying, the word end is not present in the first line. Right. So if you observe, these are the feature names. Fine. So, and one more observation should be this all entries will have exactly same number of column as this feature name. Right. And what will have that number, the number indicates whether the word, let's say the end, is present in the first word or not, first document or not. Vivek, your answer was correct. Why you change it? It's not padding, right? And the second word document is present. One means present. The third word first, it is once again present in the first document. We are talking about the first line. No, in this case, there is no need of padding. Maybe after understanding this, you need to answer why, right? You doesn't mean only Vivek. Anyone can answer, and so on, right? So now, can you just tell me what is the meaning of this two? Exactly. So this two, first of all, this two means which feature we are talking about. An document occurs twice. The word document occurs twice in the second example. Does it make sense? Right. And now I hope you can understand what is the meaning of individual line or individual row. This is exactly the same output that I was trying to highlight in this Excel, this example. Right. Whether first we'll check whether that feature is present or not, and if it is present, then how many times that feature is present. Right. So I just quickly summarize. what we will do over here is all the words of my vocabulary, I will consider all that words as one feature. Let's say word end is one feature, document is another feature, first is the third feature, is a fourth feature, and so on. Right? We can definitely do the stop word removal, but right now for this understanding, let's assume that these are the words. Fine. So that are the features. Now, for a given data, what we will do, we'll check whether a particular feature is present in that data. If yes, then how many times? So we'll just store that count. Fine. So all the vectors are of this size, and that value indicates 0, 1, 2. That value indicates the count of a particular word in particular statement. I hope it's clear now. Right. So this first 0 indicates the word end is not present in my first document. Right. So now coming back to you, do we need padding now? No, right? So anyhow, all the documents are of same size, and now it's meaningful representation than the label encoding. And now I hope with this explanation, all the Ramayana is clear now. Why I have generated this Excel, why I have representation, why I have done this representation of the word, and why I have done this representation of the word, right? So depends on the requirement, you have to choose the encoding. It's not always the case that you can go for the label encoding and the task is done, right? So lateral, whenever you have free time, just try the label encoding on the X and then try to predict the answer and check the accuracy of your model, right? Label encoding plus padding. If you want the code is already given in the previous laboratory, so you can just reuse that code. So try on the X, label encoding plus padding, and observe the accuracy, right? So there would be notable difference in the current accuracy and the next accuracy, right? And I want to highlight one more thing over here, that is ngram, okay, which is basically referred as the language model, or you can say the co-occurrences of a word, right? Due to the shortage of time, I cannot discuss this ngram in the depth, but right now, this 2 indicates the bigram, 1 indicates the unigram, right, and so on. So that means, and this range, okay, so before discussing this ngram, just focus on the range. So range value, let's say 2, 2. So that means just focus on the bigram. If I say 1 to 2, the range instead of this 2 to, if I write 1 comma 2, that means focus on unigram and bigram. Unigram means single word, bigram means two word, the group of two word. Fine. And if I say 1, 2, 3, that means consider unigram, bigram, and the diagram, where single word, group of two word, and group of three words. Fine. So that is actually a very helpful in a language model, right? And I guess you can relate that thing with automatic word suggestion. Welcome to, let's say, something class. So you, every one of you have predicted that the word should be ML. Fine. Why? Because the welcome and to. So that sequence, the word sequence is important. So now if you use this ngram range, and the analyzer is word, so for the word, if you use the ngram range, and let's just see the example which is given over here, the range is 2. That means we are considering the bigram. Fine. So now what we will do, instead of this individual word, that is end, document, first, and so on, now we will have the group of two words. So that means this is one group, right? And that is one feature. And I will count how many times this and is together comes in my corpus or in my statement. The second feature will be is the third feature will be the first. The fourth feature will be first document. The fifth feature will be this document, and so on. Right. So now if you observe this feature list, you can see the group of two words together. Right. And now if you just answer this, what is the meaning of this 001, I can say that you are clear with this n-gram model. Once again, which is a very essential model in terms of NLP task. What is the meaning of first 0, second 0, and 1? That is occurrences of bigram. But for this example, can you just highlight the meaning? The first 0 means? Exactly. So our first feature, that is this end this, is not present in my first statement. Fine. The second 0 indicates the second feature, that is document is not present in my first statement. Right. Remember that you have to consider the sequence. If you observe the first statement, we have document, we have word is, but now we are not considering the word, we are considering the sequence, the bigram sequence. That two word must be together and in the same sequence, that is document is. Fine. So once again, this feature is not present. The third feature is first document. It is present in my first statement, and how many time? One time. So the count is 1. And so on. So I guess now you are able to understand what is the meaning of this. Fine. And now instead of this range 2, if I just set the range as 1 comma 2, what happen? It consider all the previous feature and all these new features to represent a particular statement. Does it make sense? This is a very interesting and the very important pre-processing, or you can say the label representation task that frequently you have to do whenever you are dealing with any NLP application. સમજાય છે કે ઉપરથી? So now, if we are clear with this count vectorization, and there are some other interesting attributes of this count vectorization. So in a free time, just explore the remaining attributes. They are really very helpful whenever you are dealing with this. So now let's use that 70%. So it's a good accuracy, Mayank. Right? So now let's try this count vectorization. But yes, if you are seeing something for the first time, definitely if you are understanding it 70%, then it's a really good thing. But once you practice this all stuff, then I guess everybody can able to understand that. So let's say count vectorizer will use the lowercase, and as a stop word, we have already generated our stop word list, so we'll use that list. We'll use the n-gram feature, and let's just keep the range as 1 comma 1, right? 1 comma 1, just the unigram, right? Later you can change it to the bigram also, right? Or unigram plus bigram together. It transform name extrain. And same thing we'll do for the X test also. And if everything is good, then I should get some output. So what is the name that we have given to our stop words? Stop words without any space. So it should be stop words. Fine. So it's ready. And if you observe the output, or if you observe the shape of this training, 4101877, and this would be the 744 and 103. Fine. So can you just, now your X is ready. Now your Y is also ready. Y we have used, for the Y we have used the label encoding. For the X we have used this count vectorization method. And X and Y are ready. So now what you need to do is you need to initialize the model, model.fit and model.predict. And then later you can find the accuracy using this matrices. Fine. So can you complete the remaining code now? Naive Bayes as well as the decision tree? Or should I write that code too? Maybe let's do one thing. I will write the code for one and you can try for the other. So let's say if I write the code for Naive Bayes, you can try. So we have to multinomial. For the predict. Okay, so can you detect what is the issue? Actually, the size of this X train and the X test should be equal, and that's why this prediction is creating or prediction is generating the error. So somehow you have to make it of equal size. So let me just detect where exactly I've done some error. And parallelly, if you can find some error, then let me know. So I will update the code and let you know where exactly the error is. But I guess the overall procedure is clear to you. X the dataset v2 dot values. So I will check that and let you know. But overall, the process might be clear to you. And due to the shortage of time, I cannot able to detect the error. And I guess we'll trace back and I will update this code in the Google Drive folder. So we'll put the complete code. But once you got that complete code, try one thing. Right now, what we have done, we have set the n-gram range as 1 comma 1. So try to set it 1 comma 2 or 1 comma 3 and observe the accuracy difference. So that is a one practice that you can do. These are just the practice example. It is not the part of our lab work. So those who don't want to do that, they are free to just leave this task. And those who are really interested, they can do this. So one is you can change the n-gram range and observe the change in the accuracy. The second is we have just written the code for this naive Bayes algorithm. You can similarly write the code for the decision tree over here, and then later you can compare the performance of both the algorithm. Almost similar performance you will get, but still you can compare that performance. Okay, so I hope it's clear, and that's it for today. So have a nice day.